So here's a look at the finished skill crane that I rebuilt. I actually built a new cabinet and added sound. In this video, I'm going to cover how I went about wiring up the sound. So we'll start with the way the system works. And that is initially, whenever you add credits, the machine doesn't move until you press the arrow button. Whenever you press the arrow button, then the claw moves away from you. If you hold the arrow button down, the claw gets all the way to the back, stops, and then moves back towards you. Whenever you let go of that button, then you can no longer move that particular axis of the machine. In other words, you can't move it back and forth again. Then you can press the right arrow button, and that will move the claw to the right. And if you continue to hold that button, then the machine will move to the left and stop whenever it gets all the way and then move to the right. Once you let go of the button, then you no longer get to move that axis any longer. And at that point, it automatically drops the claw, closes the claw whenever it senses that it's all the way down, and then raises back up and returns home. Now it does that automatically. So the key here for the sound to work is you want your sound to be long enough to allow the claw to go down, allow time for the claw to retract, and then time for the claw to get back to the home position. So that's all in the timing of that particular sound because nothing else is triggered. So I'm only using 5 relays to control the axes on the claws and the drop and return. So if you understand that, then you'll understand how this system works. Now, one other feature is with regards to attract mode and the winner, winner, winner sound, which notes that a prize was given. Right now, I just have a piece of cardboard sitting in the base, and that's because I'm waiting on the infrared sensor to arrive so I can install it. But for right now, I'm just triggering the winner winner sound with a switch instead of an infrared circuit. So now that you understand how the system works, let me show you how I wired it up. First, we're going to take a look at the components used to wire up this system. And here I have the soundboard. This is a Adafruit soundboard. It has 11 different tracks that can be played. So therefore we have 11 pins. And just to make it clear, on this particular board, this is the bottom view of it. You can see the board comes with some header pins, and these are male header pins. I did not use the male pins. I went ahead and put the female pins on it because that way I can always turn it upside down and lay it down on something, and I'm not worried about it shorting out the pins. The next thing we're going to look at is the relay that I use, and this happens to be a 3 volt to 32 volt DC on the inside and a 3 volt to 60 volt DC at 2 amps on the output side. So it's a really perfect relay for the application that I'm using. So now let's talk about how I'm going to trigger the relay to activate the sound that I want to hear. This is a look at the control board, and these are solid state relays. And you see they're numbered 1, 2, 3, 4, all the way to 7. And these relays control what the crane actually does. Here is a look at the same board, but I added a header pin on the back side, and I'm showing you this side so that you can see the LEDs. There are 7 LEDs over here, and they are linked to these relays. So whenever one of these relays is powered up, it illuminates one of these LEDs. So that way I could figure out which relay controlled what function. And so now we're going to take a look at the back side of this board. So here's a look at the back side of my relay board. And I know from some testing that I did that these pins here are the trigger pins for each relay, 1 through 7. And then these pins are the output pins from those relays. Now, what's interesting about this circuit and the way this is set up, these are controlled using DC voltage. The output side of this of each relay is actually controlling an AC circuit. So here you can see how I've added the header pin, which is over here, and then I've plugged in my LED board to this, and I've also labeled each of the wires. And the way this works is whenever this relay is triggered, it's going to light up one of these lights over here. And what I did was I used a simple setup that allowed me to real quickly understand which relay was controlling what. And basically what I did was just wired everything up, and then I moved the axes. In other words, I pressed the button for the x-axis to move in the positive direction, which would have been to the right, or I held the button down and waited till it moved to the left. Now each time the crane did something, one of these lights over here came on. And of course we're looking at the back side of it, so you do not see the LEDs. Here's a look at the front side now with all my mapping done. And basically what happens is whenever you move the claw away from the player or move it forward, then we have this relay right here, which is number 4, is active. Whenever this relay is active, well, number 4, since that's the first thing that happens whenever you start to play the game, I have this LED light. So I've wired this LED to number 4 here. The next thing is whenever you hold the button, then the claw gets all the way to the back, then it starts backing up to move back toward the player. That is going to be wired to number 2, which is Y minus, and number 2 happens to be claw back. So that's the next relay to it. That's relay number 5. So relay 5 is wired to number 2. The third thing that happens is whenever you press the other button to go to the right, and that's relay number 6 becomes active. Well, that actually lights up the third LED on my breakout board here. And then the fourth one is claw left. The next task is claw down. That happens to be the next LED, which is Z minus, because minus is in the down direction. And then the next thing that happens is the claw closes, and that's going to be the last LED, or LED number 7. And then LED number 6 is Z plus, which is the claw going back up. So you can see I've spent quite a bit of time to map this out to get this so that now I know where the triggers are based on what function is going to happen. Now that we have all of that information, I can easily wire this up. And so let's take a close look at the soundboard. And we're going to mess with the first thing that's going to happen whenever we start to play. And that is that the y-axis is going to be the first thing that moves. And the y-axis is going to move away from the player or move forward. So I want to make sure that the sound on my soundboard is the sound that I want played whenever the claw moves away from the player or moves forward. And that is going to be on pin number 1. Pin number 1 connects to my relay up here on the output side. The pot on the negative side is the ground, which that goes back to the ground on the board. The signal side, which is the pin number 1, is going to go up and go to the positive side on the output. That is how this soundboard is connected to each relay. So For the second pin, we're going to have exactly the same thing, where I'm just going to have another relay. It's going to have a ground wire going to the pin number 3 on the relay, which is negative. And then the fourth pin, which is the positive pin, that is going to go down, around, and connect to the, in this case, would be the second pin, or the third pin, or the fourth pin. I'll have one relay for each pin, and they'll all be connected the same as far as the output side. Ground versus a connection from the pin number 4 to each one of the outputs on the soundboard. As far as the input for the relay now, we'll go back up to my factory board. Remember, this is AC, so we're not going to mess with any of these pins. But I am going to grab the ground pin, which is on this side. So I'm going to connect ground directly to the ground on my solid state relay on the input side. So I just connect ground. You do this to all of the relays. Then I'm going to connect each one of these pins, each one of the ones on the right here. So this here we go to relay 1, this to relay 2, this to relay 3, this to relay 4, this to relay 5. So with that said, you can understand how I wired up the y-axis, the x-axis, and the z, which the z is nothing more than the claw dropping and returning to home. So that takes care of 5, but I'm using 7, so I have 2 more left. And let's take a closer look at the 2 that are left now. You can see here I have coin receiver lamp, and that's a 12-volt input. So I'm going to send 12 volts to this relay. There's one relay that's going to be operating using 12 volts. And it gets its power from the coin receiver lamp. So whenever the coin receiver is on or lit, that means this relay is going to be active. This relay is active when the game is not playing, because when the game is playing, the coin receiver lights go out. Whenever the game is in standstill or there's no one playing, and there's no action on the game, then that means there's not going to be any sound playing, and that's when I want the attract sound to be playing. So I have it wired up to the coin receiver lamp. I also have the prize sensor wired in to this relay, so that whenever a prize is detected, then the winner, winner, winner sound will play first, and then the attract sound will play. And the way I achieve that is pin number 6 happens to be the sound that plays whenever there's a prize in the chute, and it only plays once. And then pin number 7 plays the attract sound. If there's a prize in the chute, then obviously that switch would have gotten pressed. When that switch is pressed, then the sound that's played is the winner, winner, winner. Once that sound plays, and it only plays once, then the next sound plays, which is the attract mode. So as long as the switch is not pressed, then it's only going to play the attract mode. If it's playing the attract mode and this switch is pressed, then it's going to stop playing the attract sound, play the winner, winner, winner sound, and then continue with the attract sound after it started over. Whether I get the attract sound or I get the winner, winner, winner sound is going to be dictated by the condition of this switch. And I'm actually going to be replacing this switch with a sensor, an IR sensor. So there's a quick look at how I went about wiring up my crane for sound. If you have any questions, feel free to send me an email or leave a comment, and I'll get back to you as soon as I can.